A sample of carbon-11 has a half-life of 20.39 minutes. How many grams do you have if it has an activity of 3.1 times 10 to the 13th counts per second? Okay. Well, the grams that we've got, grams will equal the number of moles that you've got, right, times 11.0114, right? Okay. Well, how do you get the number of moles? Well, the number of moles is going to be the number of atoms over Avogadro's number, right? All right. So how are we going to get the number of atoms? Well, the number of atoms we're going to get from activity is decay probability times number of atoms. And we have this is our activity, right? Okay, so all we need is the decay probability. So the decay probability we'll get from ln2 divided by this, by the half-life, right? So let's start with that. I guess that's where we start. So the decay probability is ln2. Okay, and notice that this is minutes. Notice that this is counts per second. So we better get the decay probability in per second, not per minute, right? So I'm going to divide by the half-life. But it's got to be seconds. So the half-life is 20.39, and that's minutes. And then I have to multiply by 60 seconds per minute. All right. So, and the reason we need this in per second is that we're going to relate it to an activity that has counts per second. If it was counts per minute, we'd be set, but it's not. Okay, so ln2 divided by parentheses 20.39 times 60 end parentheses. And I'm getting that the decay probability is 5.6657 times 10 to the minus 4th, and that's per second, which is exactly what we want, right? So now we can figure out the number of atoms we've got using this, right? Right, so it's the number of the activity is 3.10 times 10, to the 13th. And then that equals this decay probability. Okay, times the number of atoms. So now we can find the number of atoms. So 3.1 E13 divided by that number I just got is a measly 5.471 times 10 to the 16th atoms. It's a 6. All right, and now we can figure out the number of moles. Right, so it's going to be 5.471 times 10 to the 16th divided by Avogadro's number, right? Won't even be a whole mole, right? Okay, so divided by 6.02 E23rd, and that is 9.088 times 10 to the minus 8th moles. We almost have the right answer, okay? Now we're going to turn it into grams. I'm going to multiply by 11.0114. Okay. So times 11.0114. And I get surprisingly close to 1.00 times 10 to the minus 6th grams. Ta-da!